This chapter is about text pre-processing. Now, why do you need to pre-process any text? Now, this is must. Now, how do we do it? So, text processing is, before you do any NLP application, or before you do any machine learning application, what you do actually is you clean your data, you standardize your data. Because, for example, you're building an application, you are scraping a lot of data from internet, and all that data is a messy data. So what you need to do that, you need to clean it. You need to have some kind of standardization there. You have to, remove noise there. And once you clean it, then, your application will be really good. Have you heard about something called GIGO? What is GIGO? A lot of people know it. Garbage in, garbage out. So if you have a text that is not cleaned, that is not structured, you are giving garbage to your model and you are getting garbage out as a output. So you have to be very, very careful. So that's why text pre-processing is crucial for NLP. Now, what are the benefits of text pre-processing? Okay, let us see. It will handle spellings. Okay. It will also normalize your text. Now, what is text normalization? I would talk in next step. And then it will, have a relevant data for training. Now, these are some of the things that is important. Ultimately, in the next slide, we'll learn how to process the text. Okay, so we all these things here where, how would you, handle if you have a lot of accented characters? How will you, do the lowercasing? How will you handle numbers? All these things, I would talk about. But you go at the bottom here. Here is something called all these things, the above ones, where you are, if you are given a text, it will have a lot of, accented characters, lowercasing, numbers. It will have a lot of, punctuation marks. It will have a lot of white spaces. It will have HTML tags. It will have, contractions. Then, it will have emojis if you are, scraping text from Twitter. It can also have email address and stuff. All these things it can have, and I will quickly go through it. But what is the heart here of all of it? There's something called lemmatization. And this is something that we will learn now in the next section, that what is lemmatization. And this is the technique that is recommended and where my lecture would be focused for today as well, little bit of it. And let us learn what is lemmatization. And all of these things that we are doing something called text pre-processing. We are cleaning our text, right? Okay. Now, why cleaning of text is important? See, today I want to build an application, and you went on and this is very much, all the engineers here, they know, if you're building application, you're going on internet and scraping a lot of data. It's, you need data, from some company, and you're building, your handbook here, and all the data that you have. What does it contain? The data looks like this: hello world. Here you see that it's lowercasing. It also has numbers, 25 degrees Celsius, 100%, where there are numbers into your data. Then there are also, all these scientific characters there. Then here, when you scrape, you also have these kind of tags, HTML tags, when you scrape, scrape your data. Now, then you also have these emojis, right? Then you will also have these emails, contact us at example.com, right? Then you also have, stop words. What are stop words? Stop words is like the, and, so these are stop words. Then, we also have something, I'll come to the stemming and lemmatization in the next, in just next slide. But then you also have these tags. So moment you scrape your data, you have all these different things, and you need to clean your text. So see how neat the text looks when you clean it. And there could be different, examples of cleaning it. Now, see, such a big text, once you clean it, it looks so neat, right? It looks absolutely neat. Now, there are different ways. Maybe for some applications, numbers are important. So we are keeping numbers here. And maybe for some application, numbers are not important. So we are not keeping numbers. Now, how are we doing it? So depending upon the application again, but here I have done aggressive pre-processing. Maybe you don't have to do that aggressive pre-processing. I used everything. Now see, the text becomes so clean. It has removed everything. Now, maybe you have an application that you don't need to remove numbers and you want to keep it. Yes, why not? Then we keep it. So depending upon the application again. So now let us quickly see. Okay. Now here, just an example. So the previous example that we had, all the text was converted to lowercase. We removed here, all the text was converted to lowercase. Then we removed, the numbers. We also removed punctuations like this. We also removed extra white spaces, right? We also, expand the contractions. Don't become do not, because don't is not easy to, it's not clean. It's difficult to, when you process your text, this information can be mixed. Then, we are replaced these emojis. This emoji was happy. We actually replaced it with the word happy, right? And this emoji was this, and we replaced it with the word called angry, right? In your text, when you are, doing some kind of policy update, you really don't want that policy is coming from which website. So you remove it, right? So you remove it, URL. Now for email, you don't want email contact at, because we really are, kind of processing the main text. So we remove here. Now we also remove the stop words, which are the, etc., except. But see, if you remove the word like not, doesn't it change the meaning? So I don't want to go to work today, and I remove the word not. So there are some exceptions that, except not. Do not remove this word, right? This is also a stop word. Stop words are basically, I am running. So then, I'm running, then your am or your is, these are your stop words, and you want to remove it. And then I come to stemming, and then also, hashtags that you want to remove. So everything is removed. Now your text looks so damn clean, and now, you are not putting garbage in. Now, you are putting, good stuff in, and when you will have results, you will have beautiful output, right? So all this text processing we have to talk about when we are building the project, that from where the data is taken, how are we pre-processing it, and once we decide the pre-processing step, you don't have to do all these corrections, but there are some that you would like to do, but it's very debatable. But you see, this is much more cleaner, right? Okay, let's go to the next. So this is another example here of the same thing. So here in this one, we wanted to keep numbers, so we are keeping it. This was for different applications where maybe you are not giving a kind of contextual information that how is the weather today. You're just telling it very general. Today is hot. Today is cold, right? You are giving it much more precise information that today is 25 degrees Celsius and 100 humid. So in this cases, you would not, you would not remove it, right? Okay. So this is all good. This is again a repetition. I think it's clear what is text pre-processing, how we do it. And now let's come to the two parts that I was mentioning it since the beginning. That what is stemming and what is lemmatization. Sorry guys, just yeah. Now here, let us quickly see what are these two things, stemming and lemmatization, and why did I said that we should emphasize on it a lot. Okay, so lemmatization means what? In the lemmatization, we actually want our text to be super clean and super super should have the context that is maintained. Because what we are trying to do is we are creating a kind of application where we are actually chatting with the with your computer, or where we want your machine to understand the language. So it's something like human understands it, right? In the same way we want that your machine should understand. Now to do that, right, to do that, if you have lemmatization is that it corrects the grammar. So if you have you know text, now what it does is it removes the verb that is working, works, or work, to directly work. That means ultimately lemmatization is bringing your words to the its main word. Sorry. It is converting it in the main word. So all these words are in the text, but lemmatization converts it into the main word. What it does, it really helps in a lot of things. I will come up in the next slide that how it is helping. But for example, here your word studies, studying, studied, what is the root word? Root word is study. So all these words will be converted into study. Now your words like work, working, they are converted into work, right? So here your verbs like am, are, is, they are converted into be, right? It's a root word. So main word or the root word, how you want to put it, but this is what it is doing. Right? Root word is another way to think about it. Okay, it's somehow I need to go on the text if I'm right to draw. Yeah. So it's a root word, right? Now, here, root word or the main word, it's bringing your text into it. Now, what are the libraries? So for this, you have to remember this thing, that there is a library called NLTK, right? Which is the, one of the Python libraries that can do all these tasks for you. So you should have, these things very much clear that, as for, your Python, when you do your regular code, you call libraries such as regular expression. Now you are calling libraries as NLTK, right? And now all these libraries you will call in your code, and they will do all these kind of things automatically for you. And here I am calling, something called, I will talk about it here. It's a, we are importing WordNet Lemmatizer. So it is again a Python library. We import it, right? I'm not talking about tokenizer now. I'll talk about it in the next slide. So for example, for lemmatization, this is the library that we are using, and you can clean up your text, right? Also, ChatGPT and any code producing, software should be able to help you these days, because thanks again to this technology, that you can generate, I think, 90% of your code to do your NLP task by directly using Claude or by directly using ChatGPT. And it's you have to do iteration, but it tells you which libraries to use, and it does a lot of jobs simple for you. But that doesn't mean that we should take our knowledge for granted. We should have a little bit information that what are the famous libraries, because every day there is some kind of change. So overall, what I wanted to say from this slide is that lemmatization, what it does, guys, it converts your different words that you have to their root word, right? Root word, you see that a word can be represented in its different form. This is English language, right? And lemmatization, it converts it into the root form, a root word. This is lemmatization. Now, the library that we are constantly using is NLTK, and we are just importing something called WordNet Lemmatizer that will convert your this text to this one. That was the main takeaway from this slide, right? Okay. Now, then there is something called, now this is little trickier. Maybe you do not totally understand it today, but you will understand it in the future slides. So one is lemmatization, other is stemming. Stemming is brute force. So what is a brute force? That it has nothing to do with its English language or something, nothing. Here you simply decide that you want to have your knife and you stem it somewhere, and you just stem it here. So here all the word like changing, it became, see here there is a lot of lack of information, right? But still this has totally changed the meaning. This was something called changing, but it became into something called Chang. It looks to me like an Asian surname here, right? Studying, so we chopped it here. Stemming, you know what is stemming? Stemming's chopped, right? So here, and then it comes into words like study, right? Still we constantly see, why am I doing it, right? Like all these words which are initially like this, they are getting converted into words like this. There is a reason to it, which we'll talk about. But for example, here, as you see, all these words. So how the stemming is done? So guys, again, you see, we are using a library called NLTK, same library, and we are now calling a stemmer, which is Porter stemmer, right? So this is a stemmer that we are using. Now, what does the stemmer do? it just, so what is behind it? Behind it is certain kind of vocabulary where, you know, all the words, they are converted into a particular word. So that is why all these words, they are converted. So here it did a job, correct, that it converted it into the root word, but for other ones, it changed its meaning, right? So why it is important? See, look here. Stemming is a text normalization technique that reduces, okay, their word to their base or root form, but it involves crude heuristics. So it's like very brute, right? And it can reduce the dimensionality of your vocabulary. That means, you know, this is helpful if you have a low computation, if you really do not care about accuracy, but you have a very, very poor computation. Like, you know, there is a company who just want brutally to just, you know, I do not want to classify my reviews into, you know, very sad, highly sad, you know, I just want just sad, you know, or, you know, if I have sentiment analysis, you know, there could be different category as I showed you: joy, happy, very happy, you know, euphoria, and, you know, these categories. There we need precision. For the precision, I don't use this technique. But imagine you just want, you know, your entire text to be classified as good or bad, right? Then you really care that, you know, with good or bad, even if I have the words like this, there are a lot of other words telling you that it is good or bad. But instead, what happened here was, when you converted these words into, you know, these, your computation, it became so fast. Your vocabulary, it became so fast. So depending upon your application, you know, so stemming, as I would again emphasize, it is something that is less accurate, but it makes your computation very easy, right? But it makes your computation very easy. Let me write it again for you. It is less accurate, but computation easy. But computation become faster. There is a much more increase in the computation. So do we have questions here? I can have a small discussion here, guys, between when to use lemmatization and when to use stemming. It's good.
Yeah, maybe just a quick question here.
Yeah.
Would there be any reason to use stemming other than like if we are not restricted on the CPU usage? Is it other
No,
than just
I would not recommend. No.
perfect. Okay.
Yeah.
Thank you.
Yeah. So that is stemming. Okay, guys. Right. Very good. Looks like everyone is still staying. We are 45 minutes in the class. I'm very happy, you know, and I'm able to give you a little grasp of the stuff. Now look at it here. So see, this is when we say something brute, something crude, right? So it became into run. This became to run. In this case, okay, you can, you know, say that this is still run is not a word in English. It just did brute force. That's, you know, or crude is the word. Now easily became like this. When you do lemmatization, it becomes easy. So every time it is not converting it, it's into the root form. It tries to, but then it, you know, it tries to somehow the vocabulary, and, you know, why sometimes it looks very very, when you look at it, you say, hey, easily even takes, more words than easy. But then they have developed the vocabulary, because there are 10, 1 million words in the vocabulary. So they just developed it, an algorithm where some of the words they came out correct and some of the words, they absolutely lost their sense. Now with the faster, they still kept okay stemming like this, but the right word is lemmatization. Lemmatization is a technique where, and it's the libraries are getting developed where you actually transformed into your word, but still you can stem it, and if you're lucky you get right root word, otherwise they have just chopped the last three characters, right? Okay, so this is here again, stemming versus lemmatization. So here also guys, you saw this word improve, they put a brute force chopper here. Any word that comes with improve, we do it like this. So just how the libraries are developed, there's not sophisticated library. But with lemmatization, you see, it's much more sophisticated. Every word improving, everything word becomes like a real root word. But they tried it when they started developing the library, but ultimately there were 1 million words. They developed it, the library based on, okay, if we are lucky, we get the root word, otherwise improv. It's absolutely changed the meaning here. But again, this is a technique which is used if you have very bad computation. People have been using it. Remember, guys, in the past, before we had transformers, still we had, Siri and everything working on the previous technology, and they were not doing very sophisticated jobs. But we didn't have, this kind of drive to have so many GPUs involved. Right now, there is a drive in the entire world to maximize GPU, to look for a better alternative for the computation. So that was the time it was all developed. Okay, without further ado, we should also do a little code. But I hope this is clear now. Okay. Now, this is interesting here. See. So this is very interesting. So we do here, when we can use, stemming. So when we have, task like indexing or a task like basic keyword matching, where we do not really care about accuracy, we can use stemming. For example, we can, extracting, locations somewhere, you have museums and you just want to match the word. Sometimes, uh, it does a job for what is the keyword matching. That's something I would, you know, get there. When you submit an article, when you submit a paper, there are certain keywords that you write, right? For this boot camp, you wrote the keywords like NLP, you wrote the keywords like LLM, and you wrote the words on internet, something called LLM, NLP, what else, transformers, or something like maybe AI agent or maybe RAG. These are the words they're doing, and now your algorithm is matching those words and giving you my bootcamp link. Now this is keyword matching, right? So such kind of a thing where the keywords are matched, they say that it will work, but it works the best in the controlled environments. You cannot, how to say, go wide with it, that it will do any kind of keyword matching. But if it's a small project, like my project that I'm doing right now, I have a vocabulary of 20-30 words, and I can write a stemming, my code that it stems all the words into these particular words, and then anyone searches it matches. So a lot of customization can also be done. Now for such thing is a keyword matching. Same is for the search engine on Google. because it's just a computation thing again. Okay. I think it's kind of a repetition of the knowledge, but yes. In right. Why now here? This is the thing, lemmatization, right? Sorry. I have to look for an alternative tool to teach. This is slightly, back and forth. Okay, so this is a context-based task, right? So what is a context-based task? Context-based task is where you really want a clean text, but we want really to improve computation. Here, guys, computation is everything into this language, into this technique. You see here running. So here text is the running shoes are comfortable. The lemmatization does the run shoes are comfortable. It still preserves the meaning, but now your word has become smaller, right? And if it is a text which consists of 10,000 words, now 10,000 words, every time your suffix is removed, and still your text is there, right? So the run shoes are comfortable. So it is putting it here where the stemming does the run shoe are comfort. So it kind of loses its meaning, right, in stemming. So that's why the lemmatization is done. Now, what is a context sensitive task? So context sensitive task is the one that I told you, the sentiment analysis kind of a thing. When you do Amazon reviews, if you're doing a very broad categories, you will be fine with the stemming. But if you're doing a very precise classification, you're fine with the lemmatization. Yeah. So they just say stemming may incorrectly reduce words and lose sentiment information. So somehow this is just way to understand what is stemming and lemmatization, because this is very commonly done to faster the computation, right? Okay, very good. Okay, guys. Now, I think we should do okay, let us do a small code before getting in a little bit deeper here. Okay, guys. So such big presentation, but a small code, right? So see, in the real world, what is happening? So I'm doing right now on Google Colab, and a lot of codes that I have developed for this bootcamp, which are a little bit sophisticated. For that, we will use Visual Code, and this is Colab. So Colab is something that people should know that it is coming from Google, and it's something. It's a IPY NB notebooks. Generally, you can also do .py here. And what is happens is this thing runs on the cloud. So everything is installed on the cloud, and every time you run the code, your installation is done again and again. So this is kind of little bit gets very boring at the end, that you have to install your packages again and again. So, but most of the people here are already software engineers. So it should not be a problem for them to use VS Code directly. But Colab is good for small codes for sharing purposes thing. Now this was about Colab. Now let us see here what is the code looks like. Yeah. So here again, we are using packages. See, what packages did I use? See, guys, these two packages, right? SpaCy and NLTK. They should be on your fingertips. They are very competitive library. One is spaCy. Oh my God. sometimes slows me. It is spacey, and other is wipes. Okay. One is spacey, and other is NLTK. They are important, very important. Especially NLTK was developed in the previous time, whereas spacey is still being developed. So you can do a lot of customization in NLTK. In spacey, there is a less scope of customization, but you can try both. They do both very similar kind of jobs. Now, I'm installing here spacey NLTK. I'm also installing here, something called contractions. I'm also installing here something called spell checker that will check your spelling, right? And something called gdown, but this is for mostly for working purposes. So I have installed these things, and you can install them in either your Jupyter or VS Code, whatever you're using. Now, after that, what I'm doing is, this is some kind of system message, which should not be worried so much. But look here, what exactly did I use in terms of the code? So easy, so easy. So once you import the libraries like spacey and NLTK, and thankfully, everything in AI and machine learning, the code is very, very easy, because everything is library based. You are not writing and typing yourself. Yes, if you have to do functions, and if you have to customize functions, go to more sophisticated kind of tasks, you have to write. But for general tasks, there is no need. You call libraries, and you should know which one to call, but some of them, it will become, your everyday job. Okay, I have to call NLTK and maybe spacey, and they do it. Now, so what are these libraries? We know that there is a big, so basically a big code, a very big code. And in that code, it's a Python notebook that I'm calling. And all these are functions inside that notebook, right? And so there's a Python notebook that we install actually. From that Python notebook, there are functions. And those functions are directly, right? They're directly handle HTML tags, handle accented characters, handle special characters, lowercase text, handle URLs, expand contractions, handle white spaces, handle emojis, remove mention, remove hashtag, right? Then after removing hashtag, handle numbers, remove stop words, and they have also on stemming, and but this is just for your demonstration purposes, guys. So here we have both on, right? We also have stemming and lemmatization, both are on here, right? So we have added all the functions, right? And after that, what happens? After that, once all the functions you install, all of them here, then you are simply, if as a coder, you know that here I'm overwriting my text. I have a certain text. First of all, that text, it removes HTML tags, then that text removes accented characters, then the same text removes. So if you see here, I'm not making it text 1, text 2, text 3. It is the same text that is getting overwritten, right? And all these text is getting overwritten, and where all my characters are getting, here we are doing initial cleaning. Initial cleaning means remove HTML tags. So if today you are scraping a website of a company, it will have HTML tags. You need to remove it. Accented characters, remove it, because it's some characters are coming, maybe some French is involved there, and then special character, remove it. Now remove here, lowercase. Generally lowercase is easier, just it handles it in one way, right? Now you're also handling the URLs here, right? Now, then you're expanding contractions. Don't becomes do not, which is important. Then you are handling the white spaces. So the sequence is initial cleaning. Then you are normalizing the text, kind of, you're making it in a lowercase. Then you're expanding and cleaning it. And then you are handling remaining elements. Your remaining elements are emojis, your mentions and hashtags. And then you are making that lexical normalization is the term that I was looking at. This is the term known as lexical normalization, where you're reducing the width of your word. And here you can use this, right? This lemmatization and this. And now we are returning text, right? So here, if you see in this code, I have made everything, kind of mute, just to show you, right? Make sense? Okay. Now I had this text here. See, this is French, and people sitting in Canada, they know these words: resume, facade, Joe. I speak French, so I understand it. But other people, this is French, guys. So resume, Joe, facade. This is a 50-word text. It has it's a very dirty text from somewhere. It also has this kind of, paragraph or some kind of, looks like HTML, but it's more like, doing a paragraph. Can't do it, right? And I love this. Here is also this. Check out my website and things. And then this was your text original, and I say please print the text, and it's pre-printed after pre-processing such a clean text, right? Easy code. Okay, guys, very good, very well. So I think we understand this. You are done with one thing now. Tomorrow, I'm still not finished with the lecture, but I'll just take a pause here. Tomorrow we are doing something very important. After we have cleaning the text, how is the text converted into numbers? So all this text, it is converting into numbers. So this is how because computer is still understanding numbers only, right? Your computers, they don't understand these things. So all the text, it is getting converted into numbers. And tomorrow we will, learn that how is everything converted into numbers? What is, the real theory behind it, and what are the main takeaways that we need to have, to understand this. So now what you did today is you you were first of all very patient. You went through, entire step that you scrape some text from internet, you were able to clean it. Now after you have a clean text, then what I do with that clean text is I convert them into these numbers, right? And how it is converted into these numbers, uh, there is a lot of understanding behind it. And once you understand it, then you can take important decision, right? You can really take important decision while making applications, right? So this is very, very important. And tomorrow we'll deal with it. I'm very excited about tomorrow's lecture. But meanwhile, let us finish very quickly, with some very quick things. And what I'll do with everyone is, this is kind of a syllabus that we developed. Now, in this syllabus, there's a link to each slide here. And I will give it to you, and I'll keep, I don't want to give you everything together because, there are times when I do modification. So whatever I teach, I would only give you that, right? And I can give everyone this Excel sheet, plus these Excel sheets are linked to these slides. And now you can just click on them and you have them. Now you can also click on them and you should have them. And if anyone has access issues, they will contact me and I'll try, my best. So for today, I will give you, we did introduction slides. Then we did something called, here, data processing slides. And then there are some documents that I have developed that, you can go through them For example, in the pre-processing steps, there's a document that we have. So this is just, a guide for you to quickly go through them. And, you can just see here which library to use very quickly, or which code to write. For example, anyone is scraping website. We all know BeautifulSoup here. Everyone knows BeautifulSoup. If I do this, I can scrape, any website in a minute. But the scraped website, it comes up with a text like this, right? Because this was a paragraph in HTML language. So we need to clean this text. So overall, what I'm trying to say is, I will give you this. You have links. You also have some extra documents. This was Kathy's your question. I have provided a lot of extra documents within here, right? So you can just go and look into them. This knowledge should be enough. Idea is not to have you look on internet, because this will just distract you. We have to be very efficient in learning this entire technique, not losing our focus, right? Okay, so I will provide this thing to everyone after the class. I'll also provide the recording so that you have it. I'll try to also publish it on Jadu page, and we can make it private after few days, so everyone has access to it. Okay, now going back there to our slides, these were some general information. Now this text, this one that we have now, we understood that. So here, very quickly, I can cover it. So guys, we did something very excitedly about lemmatization and stemming, but the rest techniques are very simple. And you will do that from NLTK corpus. That you just saw, right? Sorry. Why it's happening? Okay, why? But I'm on a slideshow. Just a second, sorry. Okay, yeah, my bad. Okay, we just see, guys, from NLTK itself, we imported together, there was a big line that I was importing there. And here I did stop word and I imported it. And here you can create your own function as well, right? And you can create your function, so this one is, once you import this thing, now, so stop words are something that this library would just tell you which stop words are these stop words, right? And then you create your function using this stop words, and you say here, stop. So from the text that you will input, right? From that text, you can create a kind of a set of words, right? And that will give you the stop list. And now, either you can remove them at the end, it's your choice, or you do not, right? But this is a function to actually remove. And then tokenization is a token that I'll talk about tomorrow. But this is basically not required only for very sophisticated coders. Generally, you will use only, this line from NLTK import stop words, as I showed you in the code, and it will do maximum of your job, right? You don't have to really do the code that I told you. This is just more, more kind of way that you can create your own, codes. You don't have to use any library. So you can here create your own code that, you are using handle URLs. Now you can create your own. Here I'm just a regular expression, and I am creating function, not needed for you to create your own. I would say use this automatic built, thing. I provide this because sometimes people wants to do some customization and want to do very high-end projects that I do with a lot of, companies here. And then we develop our own code. So it is just FYI kind of things. And this FYI I have provided in every slide, so that you can create your own little functions. You can import contractions in the library, and then you can, use your own functions. And this will can't become cannot, and this is, and they're, separate functions. Here, this function will handle your HTML tag, right? So this is a separate function. But as you saw, you import NLTK, you import Spacey, and you import all these things, text pre-processing. So all these things, these functions here, they are already taken into text pre-processing there. I'll go back. So these are the individual functions. Okay. Now, this one was the same thing, handling white spaces. You don't want white spaces like here and it becomes cleaner like this. Now, you don't want here, things like, you see here, $20 extra comma, you don't want punctuations, you want to get rid of. There's exclamation mark you want to get rid of, right? This is a string, so you don't get rid of these quotations because they just tell you they're strings, right? Right? Okay. Handling numbers. If I have 2 dogs and cats, if you remove the numbers, I have dogs and cats. Somewhere you need precision, I have dogs and cats. It was a number, it's a number. This is how, replace with a number. Num. So depending upon that. With a special token like num to indicate the presence of a number. So this will just tell you that it's a number, right? Then we have a lowercasing. Here we are doing lowercasing. So this is again a function. We provide it because somewhere if you are doing sophisticated code, it is important. This is just handling accented characters, but actually you have this code where you are using this function, pre-processing functions, and they are doing everything on its own. But then you cannot do any customization, right? But for most of the application, you can deal with it, right? So this was it, guys. So this is a little code you can try today to play with dirty text and can improve it. And tomorrow I would talk about how you convert words to numbers. So yeah, stay with me and I will forward you these chapter links so that you can play. So any questions? We are on time. Any question, guys? I'm open for any question now. I think there is no question in the chat. So guys, see you same time tomorrow. I will provide you with recordings and these things. Sounds good?
Thank you.
Thank you very much.
Thank you so much.
Okay, bye-bye. Take care.
Bye.